All right, so with that, then let's go ahead and look at the type of problems you can expect to see on the exam. So the first one is if you refer to page 162, 163 in your textbook, problems 21 through 48, you'll see a problem similar to this on your exam. So we'll work through problem number 24 here. So this really is just using the quotient rule. So if we look at what is our f function, that's 3x to the 4 plus 2x. And our g function is x cubed minus 1. So we take the derivative of each of those, and we get that our f prime is 12x cubed plus 2, and our g prime is 3x squared. Okay. So using the quotient function here, we will take our g f prime minus f g prime divided by g squared. Okay, so that gives us x cubed minus 1 times 12x cubed plus 2 minus 3x to the 4th plus 2x times 3x squared. And all of that is divided by our g squared. Okay, so we will do the FOIL method for these two terms. We'll also do the FOIL method for these two terms. And that gets us 12x to the 6 minus 10x cubed minus 2 minus 9x to the 6 plus 6x cubed, all of that divided by x cubed minus 1 squared. So the last thing we want to do is distribute that negative to both of those terms and simplify. And so we end up with 3x to the 6 minus 16x cubed minus 2 divided by x cubed minus 1 squared. Okay? Question. All right. So for this next kind of problem, page 71, it'll be in the problem section similar to number 19. So this is where we're using that extended power rule. Okay, it's like problems 1 through 32 in the textbook. So we could see here that our f function is this 5x plus 2 to the 4th, and our g function is 2x minus 3 to the 8th. So when we do our extended power rule, we get 4 times 5x plus 2. Really, 'cause remember, we're just bringing this down into the front. And then we degrade this here, the exponent, by 1, and we multiply it by the derivative of the insides, which is 5. So we can simplify that to 20 5x plus 2 cubed. Okay, when we do the same thing with our g function, we get 8 times 2x minus 3 to the 7th times the derivative of the insides, which is 2. So that will be 16 times 2x minus 3 to the 7th. Okay, so now it's just the good old product rule where we have our fg prime plus gf prime. And so that is going to be 5x plus 2 to the 4 times 16 times 2x minus 3 to the 7th minus our g, not minus, plus our g, which is 2x minus 3 to the 8th times 20 5x plus 2 to the 3rd. Okay, so now what we can do here is we can let's just move the constant here to the outside, right? So we have 16 5x plus 2 to the 4th, 2x minus 3 to the 7th, plus 20, 2x minus 3 to the 8th, 5x plus 2 cubed. Okay. So now we want to do, we want to factor out some common terms. And so we can see that with our constants here, we can factor out each of those. We have a 4 value in each of those, right? So we can factor a 4 out of each of those. Then when we look at the 5x plus 2, the biggest exponent is a 3, so we could take 5x plus 2 to the 3rd. We can factor that out of both terms. And then finally, the 2x minus 3, one has to the 8th power, one has to the 7th. So we could take 2x minus 3 to the 7th power. And so what does that leave us with, right? So when we take that all out, when I factor all of that out of my first term here, when I take 4 out of 16, that leaves me with 4. When I take 5x plus 2, I took 3 of them, so it's leaving me with 1. So I have 5x plus 2. And then I took all 7 of these, so I don't have any left to put inside the parentheses. Okay, now we do the second term. So plus, I'm going to pull, when I pull 4 of these out of the 20, that leaves me with 5. And it'll leave me with 2x minus 3 to the 1 power. And then I pulled out all of the 5x plus 2. Okay. So the last thing we need to really do is let's just clean this piece up right here. And so that's going to give me a value of 4 times 5x plus 2 cubed times 2x minus 3 to the 7th times, when we do this, so multiply this, add it to this, we end up with 30x minus 7. Okay? Questions? All right. So the next problem is we're just solving for higher derivatives. This case, this is asking us to solve the 5th derivative, given that x to the 6th minus x cubed plus 2 is the equation we're given. So the first derivative would be 6x to the 5 minus 3x squared. My second derivative is going to be 30x to the 4 minus 6x. My third derivative is going to be 120x cubed minus 6. Our fourth derivative is going to be 360x. And our fifth derivative, x squared, sorry. Our fifth derivative is 720x. Okay? Questions? All right, so the next type of problem that we're looking at is the where we're looking at computing interest. So be prepared if you're asked to give a problem where it's got compounding interest yearly. We use n equal 1, quarterly n equals 4, monthly n equals 12, and daily n equals 365. Okay. So then what you need to do for this one, if I'm asking you to give me the value when we're looking at compounding it daily, then we're going to use n equal to 365. Okay. And so then what we have is we plug it into this first equation. So we have A is equal to our principal, which is 75,000 times 1 plus our rate. Our rate is 0.045. And then we're dividing that by the 365 days, which is our N. And then that's 365 times, and this is for 3 years. Okay. So when we simplify that at the end of those 3 years, we should expect to see $85,839.54. Okay. Questions? Okay. So if we are computing it continuously, then we need to go ahead and use the different formula. Okay, so we're going to use the A equals PRT, P times E raised to the RT. And so in order to use that, we're going to use 75,000 times E raised to the 0.045 times the 3 years. Okay, and that's going to give us 85,840.26. Okay. Any questions so far? All right, and so then the last thing that you could be asked is how long it'll take for your stuff to double. And so that would be our double time is T is equal to the ln of 2 divided by our interest rate, which is 0.45. And so it'll take approximately 15.4 years. Okay, question. Okay. So this next problem, page 210, similar to problems 1 through 24. And so this is where we're looking at derivatives of e raised to some function. So in this case, we have our f function is equal to e to the 3x, and our g is equal to x to the 6th. Okay, so our f prime is going to be our f prime is going to be 3e to the 3x, and g prime is equal to 6x to the 5. Okay. And so then we have g times f prime minus f times g prime divided by g squared. Okay, so that gives me x to the 6 times 3e to the 3x minus 6x to the 5 times e3 to the x divided by x to the 6 squared. Okay, so let's go ahead and see how we can simplify this. We have an x to the 6 and an x to the 5 that we could factor out of each term. We also have a 3 that we could factor out of each term. And we have an e to the 3x that we could factor out of each term. Okay, so when we do that, we end up with 3 x to the 5, e to the 3x. We factored those out. What it leaves us with is a x minus 2. All of that divided by e to the 6 squared, it gives me x to the 12. Okay, and I can see that I have 5 x's here, so I can go ahead and reduce that with 5 of the ones in the denominator. And so in simplest forms, I have 3 e to the 3x times x minus 2 over x to the 7. Okay, question. Okay, number 7 on page 216 is another type of problem. So we look at it here. Our f function is going to be the x to the 6, and our g function is ln of x. So when I take the derivative of each of these, I get 6x to the 5, and I get 1 over x. Using the product rule, I do my fg prime times fg prime plus gf prime. And so that's going to give me x to the 6 times 1 over x plus g, which is the ln of x over 6x to the 5. And so this gives me a total of x to the 5 plus 6 ln of x, or let's put the x to the 5 here too, ln of x. The order isn't 100%, it doesn't matter 100%, but it is more common to put the constants, then the variables, and then any like ln of anything. But the last thing we can see here is there's a x to the 5 in both of these terms. So we could factor that, and we'll have x to the 5 times 1 plus 6 ln of x. Okay, question. Okay. Now we're looking at page 248. This is where we're doing derivatives where log is involved. So the first thing we're going to look at here is this x squared plus x. So what is that derivative? And so that is going to give me my dy dx for this is equal to 5 times the derivative of the what is after the log, so that is 2x plus 1, divided by ln of 6 because of this log 6 here. And then we're multiplying that times 1 over that function, which is x squared plus x. Okay, so all we need to do for this, though, is to simplify. So we end up with 10x plus 5 divided by x squared plus x times ln of 6. Okay, question. Okay. So for this next problem, we're looking at, we want to know where the function is increasing, where the function is decreasing, and where we have inflection point. Okay, so let's do inflection point, and we want to know where it is decreasing. Okay, so first of all, let's just go to where it is increasing. So it's increasing at 1, -3. So if we go to 1 to -3, we know that our graph is increasing here at this point. when we go to the next one at 8, +7. So up here, we know that the graph is decreasing. And we know we have an inflection point at 5, 4. So that's somewhere around here. And so we can use that as a guide to help us sketch in what this graph should look like. Okay. So no work necessary on this one. I think this is probably the only problem on the exam where you don't have to show work. But if you don't label your graph, then you won't get credit. So definitely make sure you label your graph. Okay, questions? This problem was omitted on the regular exam that you all took because for whatever reason, I probably, when I was just typing them, I got the up and the down flipped backwards. And so it didn't make an actual graph because you couldn't connect the dots properly. Okay, so for this next problem, we're looking at defining some things, right? The intercepts, the asymptotes, derivatives, graphing, all those sort of things, okay? So how do we do our x-intercepts? That is where we have our function set equal to 0. So this would be 3x minus 1 over x equal to 0. We can multiply both sides by x. That gives me 3x minus 1 equals 0. And therefore, x is equal to 1/3. So my x-intercept is 1/3, 0. And remember, it must be a point, not just one value. Okay. For my y-intercept, that's where f of 0, and in this case, there's no y-intercept because that would mean I have an undefined problem because I can't have 0 in the denominator. So asymptotes, my vertical asymptote, x equals 0, and then my horizontal asymptote, that's going to be where we just look at our first term here. And so y equals 3 over x. So y equals 3 is my horizontal asymptote. When we look at derivatives and domains, my first derivative is going to be 1 over x squared. If I look at the derivative of that, that's my second derivative. So it's -2 over x to the -3, which is the same as -2 over x cubed. And then my domain of this function is going to be -infinity to 0, and then 0 to +infinity. So x can be all values except 0. Okay. So moving forward, we have some other parts that we need to do, the critical points. So what are our critical points for this? This is where our f of x is equal to 0. Since we have no solution, there are no critical points. Okay. And when we're looking at relative extrema, have -infinity to 0, and then again from 0 to infinity. So what is our test value here? Let's use -1. Here, let's use +1. And so when we plug that into our derivative, we're going to have that's greater than 0 for the negative. It'll also be greater than 0 for the positive. So that means we're increasing in both. Okay. When we do the same to test for the concaveness, that's going to be -infinity 0, 0 infinity. And so in this case, my same test value, so my second derivative, This is going to be greater than 0, so we're increasing. This one will be less than 0, so we are decreasing. For inflection points, second derivative doesn't exist at 0, so there's no inflection. And then when we look at the graph, how can we use the things that we know? So we do know that at y equal to 3, we have this asymptote. We know that we also have an asymptote at x equal to 0. And we can look at plotting a couple of points or whatever, and we would see that this graph would look something similar to this. Okay, question. Okay. For this next one, let's take the derivative of both sides. Okay, so we take derivative of both sides. We end up with 6x squared plus 8y times dy dx. Remember, we have to add that dy dx when it involves the y, and that equals 0. Okay, so we want to get dy dx by itself. So that equals, we're going to minus 6x squared from both sides, and we'll divide 8y by both sides. Simplify this, and we get negative 3x squared over 4y. We want to evaluate this for the specific slope at that point, -2, -1. We can say dy dx is equal to -3 times -2 squared divided by 4 times -1. That is -12 over -4, or a +3. Okay? Question. So that is the last of the old material, right? So now we're going to transition into the problems that are each going to be worth 10 points, and they are from the new material since the last exam. Okay, so for this first one, we have an integral, and it's we want to first convert the denominator into a fractional form. And so that's going to be the derivative or the integral of -7 over x to the 2/3 dx. And then we'll bring that x up into the numerator. So the integral of -7x to the -2/3 dx. Okay. So we can bring this -7 to the outside. And that gives us -7, the integral of x minus 2/3 dx. Okay, so using the rules of integration, then this is -7. Then we have x to the -2/3 plus 1 divided by -2/3 plus 1. And then don't forget, we have to add that plus c out there on that. This piece right here is going to be a positive 1/3. So -7 divided by 1/3 is the same as -7 times 3 over 1. So that's -21. So that is going to be -21 x to the 1/3 plus c. And then the last thing is just to put that back into radical form. So we have -21. We have the cubed root of x plus c. Question.
Professor, how did you get -21? I mean, I understand that part. I'm just like, I'm really confused on the bottom. I mean, above.
Yeah, because this is all multiplied together, right? And
Correct.
so we have -7 times this stuff and this stuff, right? We
Yeah.
don't have any numbers up here in the top, so it's like a 1,
Oh,
right? And so the number in the bottom is 1/3. So essentially, we're just saying 1 times 1/3, right?
okay.
But the 1/3 is in the bottom. So it's 1/3, it's 7 times 1 over 1/3. So it's really -7 times 1 divided by 1/3, which is 1 times 3 over 1, which is how we end up at that.
Okay. Thank you so much.
Uh-huh. Any other questions? Okay, so for this one, we're looking at the area from 0 to 5. So we could um, okay, so we're going to go from 0, let's say 1, 2, 3, 4, 5. Okay, so from 0 to 5. But this is essentially, right? This is the integral from 0 to 5 of 2x dx plus the integral from 0 to 5 of that constant 5 dx. Okay. So the easiest one is to do the constant. If I look at this and I plug all those pieces in 0 to 5, and this is 1, 2, 3. Let's do 1, 2, 3, 4, 5 right here. So that's looking at this area right here. So that's our first area. Remember, area is equal to our base times height. And so that is, so area 1, so 5 times 5. So that equals 25 for the square. Then with the 2x, that is like we can just use the rise over the slope of that, right? We're going to rise to run 1. So we would go up 2 points over 1. And then I moved over only one tick mark down here because this is 1, 2, 3, 4. So don't be confused that it's 2 lines of graph paper, but on our graph, it's only one value. And then we can move up 2 over 1, up 2 over 1, up 2 over 1. And we keep doing this up 2 over 1 till we get to that 5 as well. And so you can see that that's this area right here. This is our area 2. And so then we can see that this height is 10, where this height was 5. And so we can again do area is our base times height, but this time we have to divide it by 2 because it's not the whole square, it's only half of it. And so that is 5 times 10 divided by 2. And so that would also be an area of 25. So we would say that that integral is equal to 50 because it will be the 25 plus 25. We would add those two areas up. So it would equal 25 plus 25, which is 50. Okay, question.
Professor,
Yeah.
can you go over the how can we get the 10?
Yeah, so when you draw out the graph, right, I can now see that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units high. When we solve that out graphically. But also, if you think about it, right? If I plug in to this equation here, I plug 0 in here, right? My first value I get out is 0. When I plug 5 into there, 2 times 5x, my value is 10 units high off of that. Did that help?
Thank you, Professor.
Uh-huh.
Yep.
Okay. So this next one, we're doing an integral from 1 to e. So this is just the antiderivative. So x squared over 2 plus ln of x. And we're going to evaluate that from 1 to e. So that is e squared over 2 plus ln of e minus 1 squared over 2 plus ln of 1. Okay, we know that the ln of e is 1, and we know that the ln of 1 is 0. So when we simplify this, we end up with e squared over 2. This is plus 1 minus 1/2 plus 0. Okay, so that's going to give me e squared over 2 plus 1/2. And then we could put that on one equation. And that would be e squared plus 1 over 2, which is approximately 4.195. Okay, question. All right. So the next problem we are going to look at is a graphical one. So how can we graph these two? We're going to look at that and then determine the area between the two graphs. So we can first look at, let's just plot, if we have x is 0, 1, and 2, then our y for our first equation, what is that? And our y for our second equation, what is that? And so when we plug that in, we get 4, 2, and 0. When we plug those values into our first equation, when we plug 0 in for our second, we get 4, 0, -4. So we can plot those. We can see where the two equations intersect if we set them equal to each other. So we have 4 minus x squared is equal to 4 minus 4x. So that is x squared minus 4x equals 0. So that's x times x minus 4 equal to 0. Therefore, x is equal to 0, or x is equal to -4 equals 0, which is x equals +4. Okay, so we're looking on the interval from 0 to 4. Okay, so when we look at this, we can graph these graphs to get a visual idea. Okay, so for the first equation, we have 0, 4, 1, 2, 3, 1, 2, 3, 4. We have 1, 2, and we have 2, 0. Okay, so that's our first equation, something about like this. Our second equation, actually, let me make this a little let's just do one line so that our graph doesn't get super out of control. 1, 2. Otherwise, it'll be really long. Okay. That. There we go. Okay, and so then for our other point, we would be at 0, 4 up here again. And at 1, we're at at 1, we're at 0 and -4. 1, 2, 3, -4. When we're at 2. Okay, so this graph will be a little more something like this, and we're looking at that space in between if you're looking for graphical representation. Okay, and so when we look at that, you don't have to have the graph to be able to work this problem. It just helps you to visualize it. So here you have, we're doing the integral from 0 to 4 of 4 minus x squared. So it's our top equation minus our other one, which is 4 minus 4x, and all of that dx. Okay, so this, when we combine it into one, is negative x squared plus 4x. So when we take the derivative of that, the antiderivative is negative x cubed over 3 plus 2x squared, and we need to evaluate that from 0 to 4. And when we do that, we end up with 32 over 3 as the area between those two curves. Okay, question. Okay, the last type of problem that you'll see on the exam is this is the ones, if you remember last class period, where we were looking at substitutions. In this case, if we let u equal x squared minus 1, right? Then our du needs to be the derivative of that. The derivative of that is 2x dx. So you could see here we don't have a 2x, so we have to make one, right? So I'm going to take this. Move it over just a little bit. And we're going to do 1/2 and times 2, right? Because we need that 2x. But now I could move this 1/2 to the outside. So that gives me 1/2 the integral from 1 to 2 of 2. Let's do this x squared minus 1 to the 7th times 2 dx. Okay. So this is the same as saying 1/2 the integral from 1 to 2 of u to the 7 du. Okay, now we can integrate that u to the 7. So that is 1/2 the integral from 1 to 2 of, actually, I don't need the integral anymore because I'm just doing it. It's u to the 8 over 8 plus c. So this gives me u to the 8 over 16 plus c. let's go ahead and move that back up here. And integrate it, right? And so this gives me what we're substituting back in our u, which was x squared minus 1 to the 8 over 16, and we'll evaluate that from 1 to 2. Okay, and that gives me a value of 6561 over 16. Okay. Question.
Professor, how did you get U8? Is it 7 plus 1? Is that what you did?
Yeah, so how do you do the derivative, the antiderivative of this? Remember, that is just, so u to the 7, the antiderivative then, right? So the integral, if it was this, is just u 7 plus 1 over 7 plus 1.
Okay.
And then you have to not forget to add that c out there.
And then obviously like you did a times 2, correct? To get the 16 on the bottom.
Correct. Yes.
Thank you.
Yep. Any other questions? All right, so that is all that you should expect to see on the final exam. Again, that is 1 week from tonight. You do have unit homework that is due tonight. If you don't get it finished tonight, it'll remain, all the chapter 4 homework will remain open in my math lab through next Monday night. So you can work on that still. If you have questions, anything like that, don't hesitate to reach out, send me a note, and I will do my best to either communicate your issues through email. If not, we can set up a Zoom meeting to get that resolved. Okay. So that is all the material I have for you. It's been great having you all in class and just being able to share my knowledge with you. If you haven't already done the course evaluation, I'd encourage you to go out and do that. It closes tomorrow and won't open back up, and the opportunity will be missed. And then also similarly, if you haven't completed the knowledge survey that the school has sent out, I would encourage you to do that as well. Don't forget to upload screenshots to show that you have completed each of those for the opportunity to have 1 point for each activity of extra credit. Okay. If you guys don't have any questions, that's all the material I have for you. I hope you guys have a great holiday break, kind of have a couple of weeks off to recharge before you're starting back up next semester.
Thank you, Professor. Have a good night.
You too. Thank you.
Thank you.
You're welcome.